All right. Algebra 1 folks, thank you for joining me, Mr. Neal, today on lesson 39. Today's key topic or key idea is going to be multiplying polynomials. Okay, so you've been working with polynomials for about a week, almost a week and a half now. And today's focus is going to be on multiplying polynomials. You kind of dipped your toes into this yesterday by multiplying monomials by polynomials. Now we're really looking at binomials by binomials or binomials by trinomials. And what I really want to pay attention to today is this box method. Okay, it's not the only way to multiply polynomials, but after teaching this for a handful of years, I've really noticed it's most of my students, not all, but most of my students' most successful way and way that they seem to enjoy the most. So I want to go ahead and show you this first and then let you form your own opinion on this. And you're going to recognize that this really looks similar to some ways that you've learned to do other math, dating all the way back to elementary school with early multiplication. So I just want to dive right in here to example number 1, where it is asking us to multiply this polynomial, x plus 2, by this polynomial, x minus 5. And I don't just know that because it says multiply, right? I know that because I can see that it's these two binomials are in a set of parentheses next to each other. And when I have parentheses next to each other, it's showing me that these things need multiplied. Okay, so what I'm going to show you is this box method, what happens during this box method, and then what happens kind of the cleanup step at the very end. So what I want to do is I want to draw a box here. And what I'm going to do is I'm going to make sure that I have a spot for all of these terms. When I say all of these terms, I want this first polynomial to just sit up here. So I'm going to put my positive x here and my positive 2 right here. That comes directly from this. And then I'm going to take my next one, which is this polynomial, and I'm going to put those pieces here. So on the left side here. So I have a positive x here and I have a negative 5 here. Notice I made that negative because in here, it is also negative, okay? And then what I'm going to do is I'm just going to start multiplying these terms one at a time. Okay, so some of our exponent rules that we've been working with are going to come into play here. So I have x times x, which is, remember, when I multiply variables with the same base, I don't actually multiply their exponents, I add them. So this is what some students forget. There's a 1 up here and there's a 1 up here. Well, that means when I do x to the first times x to the first, my answer is x to the second, and I write it in this box where they meet. This one goes here, this one goes here. Okay, my next one is going to be these two, my x times my 2. Okay, so x times 2 is just 2x. Okay, my next one now, I've taken care of this x on both. So my next one's going to be this x times negative 5. Okay, x times negative 5 is just negative 5x. And then my last one in this box, this bottom right box that's empty, is just going to be negative 5 times 2. Okay, just straight up multiplication of two constants, and that's going to be negative 10. Okay, I've done all the multiplication I need to do. Okay, so I have multiplied these two polynomials like it's asking me, right? But I can't leave my answer like this. It's nice and organized, but I need to put it into one answer, right? This looks like 4 separate answers in 4 separate boxes, which it kind of is right now. I need to simplify it. What I do is I pull things out of here. I pull like terms out of here. Okay, so my first term that I see is x squared. None of these other 3 boxes have an x squared. So I'm just going to pull this out by itself as x squared. Okay, and I'm done. I've pulled this answer out. Now I'm looking at this term that has x, 2x. And I notice that this term also has x's, right? And they have the same exponent, right? X to the first and x to the first. So these are like terms. I need to add, I'm going to combine those. Combining like terms means I add things. So negative 5x plus a positive 2x is going to leave me negative 3x's left. Essentially, if you're worried about this part, add those on a calculator. If you're like, I'm not confident with adding and subtracting positives and negatives, let the calculator do the work for you. You need to realize, hey, these two are like terms. We just combine them. So I'm done pulling them out. My last thing left is this negative 10. It's my only constant in all 4 of these boxes. It's just a number. So I'm going to write it here at the end. Okay. So my answer to this, multiplying these two binomials up top, is x squared minus 3x minus 10. Okay. So my answer is not a binomial, it's a trinomial, which happens a lot with multiplying two binomials. I want to hop right into this second example on number 2. And just, it's one of those, hey, once we see this process and we start getting confident with it and following it, we're gonna be ready to dive in ourselves. So follow me along here. So now I'm going to take this first binomial, this guy right here, and I'm going to go ahead and line him up top. So I'm going to put this positive 3x here and this negative 1 here. And then I'm going to take this second binomial and I'm going to put this positive 2x here, and I'm going to put this negative 7 here. And I'm going to go ahead and start multiplying. I have 3x and 2x here. Well, 3 times 2 is 6, and x times x is going to be x to the power of 2, because my exponent rules tell me add those two exponents. My next one is negative 2x times negative 1. So I'm really just doing 2 times negative 1. That is negative 2x. I'm on to this bottom left box, which is 3x times negative 7, and that is negative 21x. And last but not least, I have negative 1 times negative 7. A negative times negative is positive. 1 times 7 is 7. Boom. I've done the multiplication. Let's pull the stuff out to get my nice, pretty mathematically correct answer. The first thing I'm going to pull out is this, my highest exponent up here. It's an exponent of 2. And there's nothing else in the other 3 boxes that has an exponent of 2. So there's no other like terms. I'm going to pull out 6x squared by itself. I'm done with that. I notice these two, just like the last problem, both have x's. So I need to combine those like terms. If I have negative 21x's and I have another negative 2x's, that's a total of negative 23x's. So I'm done with this and this. And then last but not least, I have a positive 7. So I need an addition sign to show it's positive. And I have positive 7. So my answer is this trinomial down below, 6x squared minus 23x plus 7. Let's go ahead and jump right into example 3. Okay, see if we can build some confidence. If you want to take a crack at it, pause the video, try this one, and then unpause it and see if our answers are the same. Maybe see what's different. If you did it incorrectly, go back and listen and say, hey, what did I do different? How did he get that answer? So I'm going to go ahead and line this first one up top. I'm going to show you this, actually. You don't necessarily have to put the first one up top. If I want to put that first polynomial on the left, negative 5x, and a positive 3 here, and then I want to put this second one here, a negative. Let's try that again. Started putting that in the wrong space here. I'm going to put a negative x here. Let's go back to my pen there. Negative x and a negative 4. And let's go ahead and start multiplying. So I have negative 5 times there's a negative 1 there. Negative times negative is positive. And I'm going to have 5x squared. So now I have negative 5 times this negative 4. That's going to be a positive 20x. I have this negative x times 3. That's negative 3x. And I have a 3 times negative 4, which is negative 12. Pull out your highest exponent first. I see, again, just like third problem in a row, top left box has a 5x squared. Let's pull that out. Nothing else is a like term with it because nothing else has x to the power of 2. I notice 20x and negative 3x. So 20 plus negative 3 is a positive 17x. And then I have this negative 12 left over. You're noticing on all 3 of these first examples, you pull out the top left box by itself, you pull out the bottom right box by itself, and then those other 2 combine. It doesn't happen every time, but it happens often. Just the way that we see multiplying polynomials and binomials, it's just, you see it a lot. Not every time, but you see that a lot. Let's hop into these next 3 examples here. We're going to see all 3 of these are going to be unique. They're going to have kind of their own thing going on. Let's switch up color here. Let's hit a color palette. Let's go with a nice, let's go with this green here. All right, we're going to go with green if this works. It never does. Let's try this. Green there. Boom. Okay, so I'm going to draw my box. What do I have? I'm going to take this first polynomial and put x and a negative 2. And I have the second polynomial, x and a positive 2. Let's see. X times x is x squared, right? Because I add this and this. It's my exponent rules. X times negative 2 is negative 2x. Here I have x times positive 2. It's positive 2x. And then 2 times negative 2 is just negative 4. The only variable with an exponent of 2 is this one right here. So I'm going to pull it out by itself, x squared. Then I'm going to combine these 2. Let me show you what I mean by these 2. This one, whoops, come on. And this one, right? They both have an x. Negative 2x and positive 2x, that's 0. I don't need to put 0x. Essentially, these just got eliminated, right? 2 minus 2 or 2 plus negative 2, it's gone. So I don't have that written in my answer because those cancel out. And then I'm left with this last box here, a negative 4. So my final answer looks a little bit different here, not because I just was wacky with 2 different colors. It's the first one that's not a trinomial, right? Trinomial, because there's 3 terms. This one has 2 terms. It's a binomial, which happens. Why did that happen? Look at these. These are opposites or inverses, right? So they ended up canceling out when I did my multiplication and when I went to collect my like terms. Okay, so what's happening here in 5? Let's dive into 5. This looks different, right? Why? It says to multiply binomials, but I only see one. But do I really see one? What is that thing saying right there? It's saying there's how many of these? There's 2. So it's really telling me this. Take x plus 4 and multiply it by x plus 4. Right? That's what exponents do. They're telling us, hey, there's this many of these things multiplying. It's saying this thing, there's how many of them? 2 of them, multiply them. So let's set up our box here, our 2 by 2 box. And then I'm going to see there's an x and a 4 here, positive, and x and a 4 here, also positive. Let's start multiplying. X times x is x squared. X times 4 is 4x. X times 4 again is 4x. And 4 times 4 is 16. All positives. We love that. Let's pull things out that are like terms. I have an x squared. That's not like anything else here. Then I have a 4x and a 4x, which makes a positive 8x when I add them. And then I have just a positive 16 left over. So back to a trinomial answer there. Okay. So we have that guy. All right, let's check out 6. 6 is unique. The only difference now is I have a binomial and I have my first trinomial. So that means this won't work. I can't draw a 2 by 2 box. I won't have enough room, right? I can put x plus 2 right here, right? There's this one. But when I go to put my next trinomial, I can put x squared here from this. And I can put negative 5x from this, but I've ran out of room. I need this plus 6 to be used. So what does that mean? I just need to extend this. I need one more little space here for this 6, this positive 6. Okay, my multiplication box where area has gotten bigger, I treat the rest the same. I just multiply. I'm just multiplying instead of 4 times, 6 times. X squared times x to the first is my first on this set of notes, x to the third. I have x squared times 2, which is 2x squared. I'm going to start looking at these next 2 boxes. Negative 5x times x is negative 5x squared because I add my 1 and my 1. Then I have negative 5x times 2 is negative 10x. I have 6 times x is just 6x. And I have 6 times 2 is 12. Okay, so I want to pull my highest exponent, this guy right here. So I'm going to pull out x to the third. And then I want to pull out my next highest exponent. Well, there's 2 of them, 2x squared and negative 5x squared. Negative 5 plus 2 is negative 3. And what did they have in common? They were both x squareds. I'm done with this, and this. Any other like terms? Here's something with an x, and here's another something with an x. So I'm adding negative 10 plus 6 to get a negative 4x. And then what am I left with? I'm left with just a positive 12. So here, my first answer, that is a polynomial with 4 terms, right? 1, 2, 3, 4. I can't simplify that answer anymore because these are all different or unlike terms. X to the third is different than x to the second, which is different than x, which is different than my 12, which is just a constant with no variable at all. 7 and 8 to wrap up our notes here are really just, okay, these are all great and hunky-dory, but why would I use this in context? Or where am I going to be asked to, hey, help us out in the situation by using these skills, right? Oh, here's where we're going to see that. It says find the area of a rectangle. I was telling students last week, just start before you even read anything else, draw a rectangle. Where's the area? The area is right here. I don't know it. I'm putting a question mark because it says find the area. It has a length of x plus 2. So I'm going to go ahead and put that up here, x plus 2. And it has a width of x plus 10. So I'm going to put that right here, x plus 10. Well, remember, to find an area, you do length times width. And that's what it gave me. So really, I'm taking this and I'm multiplying it by this. So now doesn't it just turn into a problem we've been doing? X plus 10. Right here, that's a plus. Let's go ahead and set up our box to multiply and figure out what the area, that part of this rectangle is. So I have x and a 2. I have an x and a 10. Let's knock this out. X times x is x to the power of 2. X times 2 is 2x. X times 10 is 10x. And 10 times 2 is 20. Let's yank out some like terms. This guy's alone. X squared. 2x, whoops, this should have an x. 2x and 10x should be a total of positive 12x. Done, done. And I'm left with a 20 left over right there. So I would say the area is, and I can list that trinomial, that is the area of that rectangle. Last but not least, 8. The length of a square board, I'm going to draw a square, is 2x minus 3. Right? Find the area. It's basically the same thing, length times width. Right? What do I know? This only told me the length. But if it's a square, all sides are the same. So I can go ahead and say, hey, I just need to multiply these two things, which are identical, right? So I'm going to go ahead and set that up. 2x minus 3 and 2x minus 3. Let's go ahead and set up my box here. 2x and a negative 3 here, and a 2x and a negative 3 here. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Again, 2x times 3 is negative 6x, and negative 3 times negative 3 is a positive 9. 4x squared is the only term that has an x squared. Negative 6 plus negative 6 makes negative 12x when I combine these, and I'm left with a positive 9 to wrap up my trinomial. This should look really similar to that lattice math that you learned to multiply. I know that that was not something that a lot of your teachers would have seen because we're old and they didn't teach it that way when we were in school. But this box method here should really, really help you organize and put some sense to where some of these things come from. And then our final answers is just really the process of combining some of these like terms, these x's here. I can't just list them as two separate x's. If they're alike, we want to combine them. You've been combining like terms for years now in math class. So thank you for hopping in to lesson 39. I hope that you've made some sense of what I showed you today. I should really put some meaning as well as to what you were doing yesterday when you were doing monomials by binomials and trinomials and polynomials. It's just instead of a one term times a multi-term, it would be two multi-term polynomials together. We're going to see you on Thursday for lesson 40. I appreciate your time and effort, and let's hop into one of your choice practices. Ask a teacher if you got a question on the notes or your practice. Adios. Bye.